First question, to draw a line parallel to a given line from a given point. So here they will be giving us an external point and we have to draw a parallel line from that point to the given line. So the question says, point P is at some distance from line AB which is 4 centimeter long. Draw a line parallel to line AB from point P. So here they have given us a line AB which is 4 centimeter long. This is the line AB, 4 centimeter long. Now they are saying that point P is at some distance from line AB. Say point P is here. So now we need to draw a line which is parallel to line AB from this point. So parallel lines means both the lines should be at equal distances. So for that I will first take AP as the radius in my compass, and keeping the compass at point B, I will draw an arc. Now taking AB as the radius, I will draw another arc from point P intersecting the first arc. I will name this point as O and join P and O. Now we can see that AB is parallel to PO. Next question, draw a line AB 8 centimeter long. Draw a line parallel to AB at a distance of 4 centimeter from it. AB is 8 centimeter long. This is a line segment. So this time they have given the distance of the other line which has to be parallel to line AB, and the distance that they have given is 4 centimeter. So for that, first we need to construct perpendicular lines, two perpendicular lines from the line AB, so that we can find equal distances at 4 centimeters, mark those points and draw the line. Now you will understand it better when I start constructing the diagram. So first I will take the compass, take a short measure of radius and keep the compass on any imaginary point on line AB. Now I will mark 2 points first to avoid confusion. I will mark a point P and another point Q on this line AB, keeping it on point P. I will take radius less than distance from P to A and draw an arc. Keeping the same radius, I will draw another arc at the other side of P. So point P will have 2 arcs and point Q will also have 2 arcs. The reason why we are taking 2 points as P and Q is for the purpose of accuracy. If we take only 1 point, that is only P, we won't get any parallel lines. We need 2 different points to obtain 2 points which we will use to draw parallel line. So as we have learned during the elementary geometry exam, we have made 2 arcs of point P and 2 arcs of point Q. So I will use these 2 arcs to draw a perpendicular from point P and point Q. Keeping the point of compass on point P, taking any imaginary radius, I will draw an arc. Now I won't change the radius, I will keep it on the arc of other side and cut the first arc. You can extend the arc lengths if they don't cut each other. Now again I am not changing the radius and drawing another arc to cut the previous arc. Now join these points and extend the perpendiculars. Now as they have mentioned in the question that we need to draw a line parallel to AB which is 4 centimeter away from it. So I will take a radius of 4 centimeter I will keep it on point P and cut this perpendiculars from point P and Q. Now these are the new points C and D. Name every point as you make them. Now join the points C and D. So this is the line which is parallel to AB and it is present at a distance of 4 cm from line AB. To divide a line in proportion to the divisions of a given line. So here they will be giving us a line which we need to divide in equal proportions as they mention. Let's read the question. On a given line AB, which is 9 cm long, mark points at a distance of 1.5 cm, 4 cm and 7.5 cm respectively from point A. Divide line CD 12 cm long in the same proportion as the divisions of line AB. So that was a very long question, but we can divide it into parts and perform the construction. So first of all, they have asked us to draw a line AB which is 9 cm long. So this is the line AB and this is 9 cm long. The next part says mark points at the distances of 1.5, 4 and 7.5 cm respectively from point A. So they have given us 3 numerical data, that is 1.5, 4 and 7.5 from point A. So now I can directly mark these points with the help of a ruler by using these measurements, but I will not do it that way as we need to construct each and everything. The more amount of construction you show, more marks you get. So I will make the use of arcs and I will take 1.5 as the radius and mark an arc from point A. The next measurement they have given is 4 cm. So I am taking a radius of 4 cm in the compass and again I will keep it on point A only. I will not keep it on this arc as they have said that all the 3 points are at these distances from point A only. So I am again keeping it on point A, drawing another arc which is at 4 cm distance from point A. The next measurement they have given is 7.5. So now taking the radius as 7.5, keeping on point A, I have made the third arc. So all the 3 arcs are ready. Now the next part of question says divide line CD which is 12 cm long in the same proportion as the divisions of line AB. So now they have not mentioned where the line CD lies. So I am making this line CD below the line AB. Now the length of line CD they have given as 12 cm. So I am drawing a line 12 cm at some distance from line AB. Now we have to join points CA and DB and extend both the lines until they meet to form a triangle. Now this point is the point of where these 2 lines meet, so I'm naming them as O. So COD is a triangle now. Now it is very easy. I will just use this point O and from this point O I will join each and every arc and extend it so as it intersects line CD. So this is how I have to draw. Extend it a little bit and repeat for all 3 arcs. I will name the new points, and as we can see, it was a very simple construction. All we had to do is only, the main part was only in the line AB and these 3 arcs. Once you are done with these things, it's very easy. I have joined all 3 arcs with point O and extended them such that they divide the line CD in equal proportions as the division of line AB. The construction is complete. Next question. Now let's move to angles. Angles are very easy and we have already learned it during the elementary exam. So the question is, draw angle ABC of any measure and bisect it. So this is a very easy question. I will draw an angle. I am not paying attention to the measurements here because it is an imaginary angle. If they mention it as acute, obtuse or right, make sure that you measure and draw those angles. An acute angle measures less than 90 degree and an obtuse angle measures more than 90 degree. These are the very basic things and I expect you know it by this time. Now I will name this angle as angle A, B, C as they have mentioned in the question. The reason why I am drawing arrows over here because these angles are running to infinity. They don't end, but whereas in a line segment, as we can see, I draw these marks because it is a line segment. If it was only a line, then I would have drawn arrows. Alright, now I will keep the compass on point B, taking any radius. I will draw arcs, 2 arcs, one on line BA and another on line BC. If you check the book, this is how they draw it. So anyways, it is correct because it is giving us 2 unique points. Now I will use these 2 unique points, taking a slight more radius. I will keep on these 2 points and draw 2 arcs without changing the radius. Now the point of where these 2 arcs cut each other, I will make a line from B, and now this angle ABC has been bisected into 2 parts. Bi as in 2. So I have divided this angle into 2 different angles of same measurement. Now moving to the next question. Here we have to divide the given angle into 4 equal parts. Before we have divided it into 2 equal parts, now we have to divide into 4 parts. The question says, draw an angle of any measure and divide it into 4 equal parts. So as they have said any measure, so you can either draw obtuse, right angle or acute angle. I am drawing an acute angle. Angle ABC. Now repeat the same process as we did for bisecting an angle. Now this angle ABC has been bisected into 2 equal parts. So now what I will do is I will consider this one part as one different angle and another part as another individual angle, and I will again bisect this angle into 2 parts and this another angle also into 2 parts, which will give us 1, 2, 3, 4 parts of angle ABC. Do not use a direct protractor for the division of angles, as you have to construct each and every diagram. So you have to use the instruments. I will name all the points. Okay, so now this was the given angle ABC. I have divided it into 4 equal angles, that is angle ABQ, angle QBP, PBR and RBC. 1, 2, 3, 4 parts of angle ABC. Next part is construction of right angle triangles. Question says, draw a right angle triangle with its hypotenuse 7 cm and one angle of 40 degree. So as we know that right angle triangles are such that they have one of the three internal angles measuring 90 degree. And here in the question they have given us one more angle which is 40 degree. And they have also given the measurement of the hypotenuse. Hypotenuse is the side which is opposite to the right angle. So this side, they have given it measuring as 7 cm. So here it is always easy to start any construction with the help of a line. So the only measure of any line that they have given us is 7 cm. So first I will draw a line of 7 cm. So this is my line AB of 7 cm. Now to proceed, they have given us an angle which is 40 degrees. So maybe I will use this data and draw an angle of 40 degree from point A. So I will take AB as the base of the angle and make a marking at 40 degree. I am starting from here. Don't get confused while using protractors. 40 degree is always acute angle, so I will start from 0. Mark on 40 degree and use a ruler to join this point with point A. Now there is a theorem in geometry which is such that when we make a semicircle and whenever we use this base of the semicircle as the base of triangle and we draw another two sides of the triangle, this angle is always 90 degree. Anyway, no matter any way I draw this triangle, this angle is always going to be 90 degree. So here we can correlate this theorem. We will use this as a base of semicircle. Now we are using this as a base of semicircle. So what if I construct a semicircle over here? So for that, first I need to have the center of line AB, for which I will take a radius of more than half. I will construct and find the center of line AB. I will take the radius more than half, draw arcs above and below line AB, cutting each other, and I will join these 2 points. Make this construction with a light pencil. Now I have got the center of line AB, which I will name as M. So taking AM or MA as the radius, I will keep the compass on point M and draw a semicircle. Okay, now it is easy. So now I can see that the line that we had drawn from point A is meeting this arch of semicircle at point C. So now I have got this point C which is on the semicircle, so it is very easy. I can join this point C to point B, which means that this angle has to be 90 degree, and this angle was 40 degree as we had drawn with the help of measurement, and this was 7 centimeter. So the given data has been represented in this construction and the construction is complete. Next question, construct a right angle triangle with its hypotenuse being 7.8 centimeter long and one side measuring 6.2 centimeter. So here in the previous question they had given us the measurement of hypotenuse and one angle, but now in this question they have given us hypotenuse and another side. So first I will start with drawing of the hypotenuse as we did in the previous question also. Hypotenuse they have given as 7.8. Be precise with your measurements. Every makes a big difference after the construction has been completed. So I will name this point, this line as AB. Again, to find the center of AB, I will take more than half of the radius of AB. Line bisect line AB. This is line bisection. I have learned it before during elementary exam. I will join this to find point M. Now from point M, taking radius as MA, I will again draw a semicircle like we did in the previous question. Now because they have given us the measurement of another side instead of angle, I will take the measurement of the side, which is 6.2 as they have given. 6.2, taking 6.2 as the radius, I will keep it on point A and cut the arch of this semicircle. From point A, I am drawing an arc to cut the arch of this semicircle. I will name this point as C. Now I will join all the points. I will join AC and CB. So ABC or ABC is my required right angle triangle with the base as hypotenuse, which is 7.8 centimeter, and one of the side being 6.2 centimeter. Next, moving to the construction of quadrilaterals. Question, draw a rhombus with its base 5 centimeter long and one angle being 70 degree. So a rhombus is nothing but a tilted square. So as we can see here, in a rhombus the opposite sides are of equal length and opposite angles measure equal. So here they have given us a side and one angle, which is enough data for the construction of a rhombus. So first I will draw a base of 5 centimeter long, line AB 5 centimeter. Now with the help of a protractor, I will take an angle of 70 degree. This is 70 degree. Now in a rhombus all sides are of equal length, so I will take a radius of 5 centimeter and I will keep it on point A, and I will mark on this line, and from this point I will make again 2 arcs, cutting the first arc from point P. Now I will join all the points to form a rhombus. So ABCD is a rhombus. Next question, construct a rhombus with its diagonal 7 centimeter long and one of its sides 4 centimeter long. So they have given us the diagonal as 7 and one of the sides being 4. So I will take the diagonal of the rhombus as base in this construction. So I will first draw a line 7 centimeter long. Now they have said that the other sides are 4 centimeter long. So I will take the radius as 4 centimeter in the compass. And just like we had drawn equilateral triangles in the syllabus of elementary grade exam, I will consider this as one triangle and this as another triangle. So taking the radius as 4 centimeter from point A, I will draw arcs above and below line AB, and from point B I will draw arcs cutting the previous arcs. Here I have taken a defined radius of 4 centimeter, as they said that each side of the rhombus is 4. So these are going to be the sides and this is going to be the diagonal, which is 7 centimeter long. I will join all the points. So ACBD is the required rhombus. Now moving to the next question. Construct a rhombus with its two diagonals being 9 and 7.3 centimeter long. So now here I am taking 9 as the base. This is line AB. So I will bisect this line AB into two parts by line bisection, taking more than half of radius and making arcs above and below line AB and joining the points of these two arcs, meeting points of the arcs, and the line AB is bisected into two parts. Now I will name this middle point as O. Now the other measurement of other diagonal was 7.3. So now I will take a radius of 7.3 in my compass and I will draw an arc cutting this line segment bisector. Now I will consider this line OP as one line and bisect this line into two parts, just as we did for line AB bisect. So line OP bisect. So again I will take a radius of more than half, make arcs above and below this line, and join. So now OP is divided into two parts. It is not much confusing, it is just the game of visualization. Now I will take OQ as the radius, taking OQ as the radius, I will draw another arc on the other side. So these two are supposed to be the diagonal of a rhombus. Now I will join all the points. Name this point maybe as R. So this is the required rhombus, this diagonal being 9 centimeter and the other diagonal being 7.3 centimeter. The reason why I bisected OP was to obtain this distance, and then with the help of this distance I made another arc on the other side of line AB. So I got the second diagonal, which was QR, and I joined all the points to make a rhombus. This construction can also be done above the line AB. It is going to give the same result as it is mentioned in the book. Next question. Construct a parallelogram with its two adjacent sides being 6 cm and 4 cm long and the angle contained by them being 55 degree. This is a very easy construction. So first I am making a line which is 6 cm long. Line AB which is 6 cm long. Now they have given one of the angle which is 55, so obviously it has to be an acute angle. So I will mark a 55 degree angle and draw the angle. Now they have said that the other side of the parallelogram is of 4 cm. So taking the radius of 4 cm in the compass, keeping on point A and point B, I am drawing arcs. Now again I am taking the radius of AB so that I can keep this radius on this point to intersect, to cut this previous arc. Now I will join all the points and ABCD is the required parallelogram with angle DAB as 55 degree. Next question. Construct a triangle ABC with AB 6, BC 4 and CA 5 cm. Describe a circle passing through the 3 points A, B and C. So first of all they have asked us to draw a triangle ABC. So we have learned the construction of triangles. They have given AB as 6 cm, so I will take AB as the base. AB 6 cm as the base. BC they have given us 4 cm, so I am taking a radius of 4 cm in my compass and I am making an arc from point B because they have given BC as 4 cm. Now they have given CA as 5 cm, so taking a radius of 5 cm in compass, I will cut this previous arc from point A. So if this is point C, AC is 5, AB is 6 and BC is 4. Join all the points to get a triangle. Now you need to understand these two terms. There is inscribe and describe. If they say you have to describe, then that means you have to make a circle such that it lies outside a given shape. Now the given shape here is a triangle, so you have to describe a circle. That means you have to make a circle around this triangle such that it should pass through points A, B and C. If they say inscribe, then you have to draw a circle inside the shape. Okay, in this question you have to describe the circle. So to describe the circle, first we will have to draw two perpendicular bisectors of any two sides of the triangle. So now we will draw two perpendicular bisectors of line AC and AB. You can choose any two sides. I am choosing sides AC and AB. I will draw two perpendicular bisectors. By this time you should be able to get used to drawing the perpendicular bisectors because we have repeatedly done that in almost every construction and also in elementary exam. So now this is the perpendicular bisector of line AC and this is the perpendicular line bisector of AB. Now the point where these two bisectors meet is the center of my circle. This is going to be the center of my circle. Now I will keep the compass on this point and take the radius as the distance till A, B or C. It is all going to be the same, and magically when I draw a circle from this point and this radius, this circle will be touching all the 3 points. This circle will be passing from all the 3 points of the vertices of the triangle, and this circle is described around the triangle. This construction is complete. So the next question says, construct a rhomboid with its unequal sides 5 and 3 centimeter long and the angle contained by them being 120 degree. Inscribe a circle in it. So here they have asked us to draw a rhomboid. A rhomboid and rhombus are two different shapes. A rhombus is a tilted form of a square, but a rhomboid is a kite. In kite, the adjacent sides are equal, whereas in a rhombus, all the sides are equal. So let's first draw the kite. They have given the sides as 5 and 3 centimeter. So first I will take a base of 5 centimeter. They have said that two unequal sides are 5 and 3, and the angle between them is 120 degree. So I will take an angle of 120 degree. 120 degree is going to be an obtuse angle. So I am drawing. This time I have drawn the angle from the opposite side. You can also draw it on this side. Now this was 5 centimeter, so the other side has to be 3 centimeters. So now I am taking a radius of 3 centimeter, and with the radius as 3, I will mark a point. I am naming this as A, B, C. Now with the same radius of 3 centimeter, I will again keep this on point C. Why on point C and not on point A? Because as I said, in a rhomboid, that is kite, the adjacent sides have to be equal. So this side has to be 5 centimeter and this side has to be 3 centimeter. So for this side I will again take a radius of 5 centimeter. From point A I will cut the previous arc. Now join the points. So ABCD is the required rhombus. To inscribe a circle in this kite or rhomboid, first I need to draw the diagonal of this rhomboid this way. After drawing the diagonal, I will have to bisect this angle ABC by angle bisection. So again, with the help of a compass, keeping on point B, which is the middle angle, I will make 2 arcs which will give me 2 points. Now with these 2 points, I will take slightly bigger radius, keeping the same radius with both the points, making 2 arcs and join it with point B. You should get used to the process of line bisection and angle bisection by now. Now I've got a new point, that is O. From O, I will have to make a perpendicular line which is perpendicular to AB this way. Why? That line will give me the radius of the circle which has to be inscribed. So let's make a perpendicular line. Assume that this is line AB and this is an external point O to line AB. We already had this type of sum in the elementary exam. So from point O, I will have to make 2 arcs, but I don't have enough line over here, so I will just extend this line AB, which is the base of the rhombus. So I have got these 2 points. Now from these 2 points, I will draw two arcs and join it with point O. Now I got a new point, let's name it as P. Now taking OP as the radius, I will take OP as the radius, and this is the radius of my circle that I will be inscribing. Magically, the circle will automatically get inscribed, touching all the four sides of the rhomboid. Avoid making minor mistakes during the procedure so that it accurately touches all four sides of the rhomboid and the circle is perfectly inscribed inside the rhomboid. Just remember this technique where we first bisect the angle and then from this point we construct a perpendicular. This technique is going to be repeated in the next two constructions, so you will get used to it. Next question. Inscribe 3 equal circles in an equilateral triangle with one side 9 cm long such that each circle touches two sides of the triangle and other two circles. So if this is an equilateral triangle, this is how they expect us to inscribe 3 equal circles such that each circle will have to touch two sides of the triangle plus two other circles. Okay, so let's construct. Here they have given the equilateral triangle with side 9 cm. So I'm making the base of the triangle of 9 cm first. An equilateral triangle is a triangle with all the sides same length. Let's name this as AB. Taking the same radius of AB, take very precise and accurate radius and measurements to avoid big differences in the end. Now I will draw 2 arcs which will give me the top point of the equilateral triangle. Join. This is my equilateral triangle. Okay, bisect any two angles. So I will bisect these two angles at the base, that is CAB and CBA. So it's very easy, we will do it with angle bisection. Join the points. Always make your arcs and other construction steps in with a lighter pencil and the main structures with dark pencil so that it is presentable to the examiner. Now I can join this third vertex of the triangle with this point because it is going to be same. Even if I bisect this angle, it is going to be this line only. Okay, so now we have got 3 lines inside the triangle. Now if you observe carefully and if you compare this diagram with the previous construction, this was a rhomboid, and in this triangle there are 3 rhomboids. There are 3 rhomboids. That is what I mean when I say that geometry is all the game of visualization. So there are 3 rhomboids. So now it must be easier for you to construct 3 circles. You have to inscribe 3 circles in 3 rhomboids. So again the same process, we need to bisect the angle and draw a perpendicular and take the radius and inscribe circle. So I am going to repeat the same process. I will bisect this angle. Don't get confused with the arcs. Pay attention on what step you are performing and which arcs are to be used during which step. Now again, this is an external point. I have to construct a perpendicular to line, say AM. So I will keep on this point, keep the compass on this point, make two arcs, use these 2 points and draw a perpendicular. Now say this is OP. So OP is going to be my radius, but I will perform a small step over here. Say this point is Q. So I will take QO as the radius and draw a circle, a very light circle, which is going to be my reference circle. Now the reason why we are drawing the circle is, even if you don't draw a circle, you can just mark these 3 points. Say O, R and T. These are the 3 points which you will be needing to inscribe circles. These are the centers of the 3 circles. So now finally this is the time to inscribe our circles. So I will take OP as the radius. Taking OP as the radius, I will carefully inscribe 3 circles such that they should touch the side of the triangle. I am making these circles darker than the rest of my construction because this is the main part of the question. Now taking O as the center, I made the first circle. Taking T as the center, I am inscribing my second circle. And taking R as the center, I am inscribing my third circle. So as you can see, this was the equilateral triangle and I have inscribed 3 circles such that every circle touches 2 sides of the triangle and 2 other circles. The reason why these minor gaps have been created is due to the minor imperfections that I said before. So to avoid these kind of things, you can either compensate it during inscribing of the circles, during drawing. You can just adjust the radius according to your convenience, or you can take minor precautions like keeping your pencils sharpened and avoiding using loose rounders and making precise measurements. Okay, now let's see the next question. Inscribe 4 equal circles in a square with one side 8 cm long so that each circle touches 2 sides of the square and 2 other circles. So according to our understanding of the question, this is how the end construction is supposed to be, with each circle touching 2 sides of the square and 2 other circles. So let's begin the construction. Now they have said that the square, each side of the square is measuring 8 cm. So first I will construct the square, base 8 cm. Let's name this as AB. Now here you can also construct the square by constructing 2 perpendiculars and the method of construction of a square. Here I am directly doing it with a protractor. Each angle of the square is 90 degrees, so I will mark 90 degrees with a protractor from both the ends of the line segment AB. With a ruler, join it and extend, taking a radius of 8 cm. And now join the 2 arcs. this is the required square. Now let's draw the two diagonals of this square. Diagonals is a internal line touching the two vertices of a shape internally. I've made the two diagonals of the square. After drawing the diagonals, I will just divide two adjacent sides of the square into two parts. So this is 8 centimeter sided square, so half will be 4. The adjacent side also I will do the same, 4, and from this point I will join it with the point where the two diagonals intersect each other. So this is kind of a star that we have made by drawing two diagonals first and then by joining the line bisections. Now let's name this square as ABCD and the center point as O. Now again we have to repeat the same process, that is we will first bisect this angle and then construct a perpendicular to obtain the radius of the required circle that has to be inscribed. If you observe, there are 4 squares that we have formed, and let me tell you, every square is a rhomboid. Every square is a rhomboid, so you can easily compare this structure with the rhomboid construction. Now again repeating the same process. As I said, the steps are going to be repeated again and again, so you will find it easy if you practice. I have bisected this angle. Now from this point, say M point, I have to construct a perpendicular. So I will keep the compass on M, make 2 arcs to obtain 2 points, and again with these 2 points, avoiding minor mistakes, minor inaccuracies, the perpendicular is constructed. First I will take OM as the radius like we did in the previous question. Taking OM as the radius, I will make a reference circle to obtain the center of 4 circles. Now say M, N, P and Q are going to be the 4 centers of 4 circles that we are going to inscribe in the square. Now start inscribing the circles. The construction is completed. Next question. Inscribe a circle in a sector with an angle of 36 degree and a radius 5 centimeter to touch both its arms and the arc. They have given us the angle of the sector. Now what is the sector? A sector is any part of a circle. So here they have given the angle of the sector as 36 degrees. So a circle makes 360 degrees. Here a part of this circle, that is sector, is of 36 degrees. So first I will draw a angle of 36 degree. Take any indefinite base and with a protractor measure 36 degrees. Now the radius of the circle of which this sector is 5 centimeter as they have given. So I'm taking a radius of 5 centimeter in the compass and I'm making an arc. A, B, C is a required sector. Now they have asked us to inscribe a circle inside this sector. To inscribe this circle, first I will have to bisect this angle. So I will bisect it. Okay, after bisecting this angle, now suppose that this is point D. So from point D, I need to draw a perpendicular to this line. I have to draw a perpendicular from point D to this line. So that is very easy, as we have seen in the construction of perpendicular lines. I will keep the compass on point D, make two arcs on the bisected angle, and using these 2 points I will again make two arcs and join. Now while joining, I will extend it such that it meets the base of the angle. I will name this point as E. So now what we are going to do is, we will bisect angle DEA. Angle DEA. So I will bisect this angle DEA. Sectors are a bit different from the previous ones. Okay, so I have bisected angle DEA. Let me repeat the process. First, we made an angle which was of 36 degrees as they mentioned in the question. After that, I took a radius of 5 centimeter and constructed the sector. So we got the sector, like shape of a piece of pizza, sector. So I got the sector. After I got the sector, I bisected 36-degree angle into two by angle bisection. After bisecting this, I located a point D on this arc of the sector. From point D, I constructed a perpendicular line to the bisected angle line. Okay. Now, after constructing the perpendicular, I extended the perpendicular to obtain point E. From point E, I again constructed a angle bisector which bisected angle DEA. Now, this angle bisector intersects this angle bisector. There are two angle bisectors here in the diagram. So both the angle bisectors meet at this point. Let's name it as O, right? I will take OD as the radius. Okay, now I have taken OD as the radius and I will inscribe a circle. Inscribing the circle in the sector, and as we can see, this diagram is so accurate. Cut to cut, the circle has touched all three sides of the sector. Next question. Draw a circle of radius 2 cm touching both the arms of an angle of 30 degrees. So first let's draw an angle of 30 degrees. First I will draw a base and then an angle of 30 degree. You can also construct the 30-degree angle. This is the angle of 30 degrees. Now they have asked us to draw a circle of radius 2 cm such that it touches both the sides of the angle. Now if we try to draw the circle directly, it won't be so simple to make the circle touch both the sides of this angle. So we will construct it. Now they have given the radius of the circle as 2 cm. So what I will do is, I will first draw one more imaginary parallel line to this line at a distance of 2 cm. So we have already done this in the previous question, constructing of parallel line at a particular distance. So for that I will locate any two points on this line first, and then I will use these 2 points to draw two perpendiculars, and then we will mark on those perpendiculars. if you remember the previous construction, you will get this process. Now I have made these two perpendiculars from the base of the angle. Now they have said that the radius of the circle is 2 centimeter. So I am taking a radius of 2 centimeter in my compass, and from these 2 points I will mark on the perpendiculars at 2 centimeter, which will give me a line parallel to the base. This is the line which is parallel to the base of the angle. Alright, now I am going to again angle bisect this angle. Let's name this angle first. Let's say this is angle ABC. Okay. Now I will bisect angle ABC. Now you have to extend this angle bisector such that it should meet this parallel line. It meets at this point, say point O. Now from point O, I will draw a perpendicular to BC, like we did in the inscribing of circles. So I will have to extend these arms of the angle to inscribe the circle. Now from point O, I will be constructing the perpendicular downwards on BC. So I kept the compass on point O. I will mark 2 arcs, and from these 2 arcs I will construct a perpendicular. OP. Okay. Now OP is supposed to be 2 centimeter, like I said. It is 2 centimeter, which means we have got the radius of 2 centimeter, and now we can comfortably inscribe our 2 centimeter radius circle inside this given angle of 30 degrees. That's again a perfect construction, and the construction is completed. Next question. Draw an equilateral triangle with one side 6 centimeter long. Inscribe in it 3 equal semicircles, each to touch one side of the triangle and their diameters to be adjacent. So if this is an equilateral triangle, they are saying that you have to inscribe 3 semicircles in this triangle such that the arcs of the 3 semicircles should be touching each side of the triangle, and their bases should be adjacent to each other. Okay, their bases should be adjacent to each other. So this is how the final diagram should be looking. So first let's make an equilateral triangle, and I hope by now you know how to make an equilateral triangle. So they have given one side of the equilateral triangle to be 6 centimeter. So I'm making the base of the triangle and then taking a radius of 6 centimeter in the compass. I'm drawing 2 arcs and joining all the points to obtain an equilateral triangle, and name it as ABC. Triangle ABC is an equilateral triangle. Now again same process. I will bisect any 2 angles in this triangle. So I'm bisecting the two base angles. Once you start realizing the patterns of geometry, you can very much predict the next steps even if you forget in the exam. All you need to have is conceptual clarity about shapes and the power of visualization. So these are the two angle bisectors, and like we did before, I will join this third vertex with this point. Now again I will bisect this base angle. I am just repeating the procedures and steps of previous constructions. If you understand it, then the concept is very clear. Now I will take OE as the radius, and I will draw an imaginary circle like we did previously in square and triangle. And through this circle I get my 3 points, 1, 2 and 3, E, F and G. So now E, F and G are going to be the points where the adjacent of two semicircles touch each other. These are going to be E, F and G, which means I will have to draw the base of these semicircles by joining these 3 points. So I will obtain a triangle inside this equilateral triangle. Alright, now it's very easy, it's almost done. Now I will take this as the radius and draw a semicircle. Be patient while you draw the final shape. It should look very presentable and accurate, and that is how you get your 3 semicircles inside the equilateral triangle. Next question. In a square with one side 6 cm long, inscribe 4 equal semicircles, each one touching 2 sides of the square and their diameters to be adjacent. Now we need to repeat the same process in a square. Like we repeated the inscribing of circles that we did in triangle, we did the same in square. This is also the same thing in square. So first of all I will construct a square of 6 cm. So this is my required square, each side measuring 6 cm. Now again I will repeat the same process like we did for this construction. Draw the diagonals and draw the line bisectors also. So half of 6 is going to be 3. Now I am going to bisect this angle. First let's name this square ABCD. Let's name this point as O. So now I will be bisecting this angle OAS. Previous questions we used to bisect angle OSA, this angle, but now in this question for semicircle we need to bisect this angle. So I will bisect it. and I will extend it such that it meets this point, this line BD at point E. Now from this point E, I will again construct a line such that it is perpendicular to this line BD. I know it's a bit confusing, but we can construct this perpendicular using a compass, drawing two arcs, and with the help of these two arcs, make arcs above and below the line. Don't get confused with your arcs, as there are a lot of arcs drawn in this diagram till now. This line is perpendicular to line BD. Now the purpose of doing all this process was to obtain this point. Let's name it as T. Now I will take the radius OT and make the imaginary circle. This circle gives me 4 points. 1, 2, 3, 4. Let's name these 4 points as M, X, N and T. Now I will join these 4 points. These are going to be the 4 bases of my 4 semicircles that I will be inscribing in this square. Now I will take this distance as the radius and draw my 4 semicircles. So as we can see here, the 4 semicircles are perfectly inscribed inside the square. Next question. Inscribe a semicircle in a sector with an angle of 35 degrees and radius 5 cm. They have said the angle that the sector forms is 35 degrees. So with the help of a protractor, I will make an angle of 35 degrees. And the radius is given as 5 cm, so I will take a radius of 5 cm in the compass and draw the sector. So now ABC is the required sector. Now they have said that we need to inscribe a semicircle in this sector. So for that, first I will bisect this angle ABC. Bisector intersects the arc of the sector at point D. Like we did in this construction, I will again have to draw a perpendicular from passing through point D, and I will extend the perpendicular to cross the base of the angle. In the previous question, we had bisected this angle, but in this question we will be bisecting this angle ADB. So I will bisect angle ADB. Now when I bisect the angle ADB, I get a point D on line BA. From this point D, I will have to draw a line which will be parallel to this line. I will draw one more line parallel to this line. So again, take a radius of AD and make an arc from the other side and join the 2 points, so we get a line parallel to AC. Now this will be the base of our semicircle. This line is the base of our semicircle. Let's name this point as O. I'm taking OD as the radius. And taking OD as the radius, I will inscribe a semicircle in this sector. So this is how the final diagram will look. Now the last question. In a circle of radius 5 cm, inscribe 4 equal semicircles, each to touch the circumference of the given circle and their diameters to be adjacent. So first let's draw a circle of radius 5 cm. This is the required circle of radius 5 cm. Now we need to divide it into 8 equal parts. So we had already learned the division of circle into 8 equal parts during elementary exam. First draw any one of the diameter of the circle. And then you have to draw a line bisector and continue it till it touches the other side of the circle. Now I will draw 2 angle bisectors. I will divide these 2 angles. I can use these points as reference. So the circle has been divided into 8 equal parts. Now I'm naming this point as A. Now after we divide the circle into 8 equal parts, we will have to draw a perpendicular from this point. Say this point is B, draw a perpendicular to B. So to draw the perpendicular, I will first extend this line a little bit and then I will make a perpendicular to point B. Now say this is point C. ABC is an angle. Now I will bisect this angle ABC. Again follow the steps of angle bisection and bisect this angle ABC. Now we get this new point D. Take a radius of AD to draw the reference circle. So taking AD as the radius, I'm drawing a reference circle, and this circle gives me 4 points which are going to be centers of the diameter of the 4 semicircles. Point D, E, F and G. Now join these 4 points to form the base of the 4 semicircles. Take half of each line as the radius and draw the semicircle. such that they touch the circumference of the circle. This is how the diagram looks after the construction. Here we finish our plane geometry. Next we proceed to the solid geometry, which will be covered in a separate video. Thank you.